So today we'll discuss about single slit experiment, or in federal you can say there is written diffraction due to narrow slit, right? So in my previous video we have discussed about diffraction grating and diffraction, Fraunhofer diffraction, Fresnel diffraction. So I guess now you know the concept of diffraction, basically the bending of light. So today we will discuss about the single slit experiment. Okay, this is a slit basically, and from here there will be 9 rays, like 1 2 3 4 5 6 7 8 and 9, and consider this is starting from here, right? Let me 1 2 3 4 5 6 7 8 9. These all are rays from the monochromatic light. Now what is monochromatic light? Basically a light which has same frequency, same wavelength, same phase, that is known as monochromatic light. So as you can see here we have 9 slits, basically 9 rays. We have to consider 9 rays. So in this 1 and 5, 2 and 6, 3 and 7, 4 and 8 and 5 and 9, basically they have same phase, right? And these all 5 pairs have same phase. Now what does that mean, that they have same phase? Same phase basically mean that their crust joins with crust and their trough joins with trough. That means they have same phase, like these 5 pairs have same phase. So now we will consider the line 1, right, and line 5 over here. I consider this. Okay, this is how they are spreading. And now here we have a convex lens, right? This is a convex lens which is known as converging lens, in order to focus the beam of light in one place, right? So it will focus it over here, right here. This is known as point P, where the all the beam will be focused. So as you can see over here, we as I said that we will look at 1 and 5. So you can see 1 and 5. So we will draw a line between 1 and 5. This is 1 and 5. As you can see over here, this is the path difference between 1 and 5, that is known as AB. We have named it as a AB. And as we know, the distance between this slit to point this like this is known as D. So obviously 5 is on the mid of 9, like 1 to 9, 5 is mid. So now this whole length is known as D by 2. This is known as D by 2. And this is basically part difference. It is known as perpendicular. And as you can see over here, we have this theta. This is theta. This is our base and this is our hypotenuse, right? So let's just discuss about the derivation too. We know that the path difference was equal to AB, right? The path difference is known as AB. Now what will happen, we know that sine theta is equal to perpendicular upon hypotenuse, and according to that image, according to that triangle, our perpendicular is AB, which is the path difference, and the hypotenuse is equal to D upon 2. As you can see over here, this is basically our hypotenuse, and hypotenuse is equal to D by 2. That's why we have put over here D by 2. So when this will multiply, it will be like D upon 2 sine theta is equal to AB. This is our equation number 1, right? Now we know for minima. Basically here we will only discuss about the destructive destructive interference, because this experiment is out of phase, like destructive interference, and for that the condition is AB is equal to delta lambda by 2. Okay, we can say that how this this AB is equal to lambda by 2. Basically, in my previous video I've also discussed about this. Like, consider if we have a triangle over here, right? If the length between this M1 and M2 is basically lambda, so now the length between this will be lambda 2 lambda. It will be basically half, right? Now what will happen over here? Basically the length between, like the path difference between 1 and 9 is lambda. It is an integral multiple of the lambda. Path difference is integral multiple of lambda. We know that this is a triangle. This is also form a triangle. It will be like this, right? So this is lambda. If we'll do half like this, so it will be lambda by 2. So this is how we can say this AB is equal to lambda by 2. That's why we have put over here lambda by 2. Now this is our equation number 2. Now we will combine these both equation, and it will be equal to d upon 2 sine theta is equal to lambda by 2. So 2 and 2 cancel. Now it will become lambda is equal to d sine theta. So basically this is order for the destructive. Like, you would be wondering that why this is a formula, the integral multiple is a formula of constructive interference, but no, this is a formula of destructive interference in the case of single slit experiment or the diffraction due to the narrow slit. Destructive interference, right? Now basically for the nth order we have only found between 1 and 5, right? What about others? So for nth order it will be equal to m lambda is equal to d sine theta, where m is known as minima. M is known as minima. Basically this minima shows the destructive interference, right? If you want to find the value of lambda, like for the minima, it will be m is equal to d sine theta upon lambda. Now according to this equation we have 3 observations, that m, which is minima, is directly proportional to d. What is d? D is a basic distance. If we will increase this distance, the minima means the destructive interference will also increase, right? There is another observation that m is directly proportional to the theta, basically sine theta. If you will increase the theta, the destructive interference will also be increased. Okay, when this sine theta is maximum, it is maximum of 90 degree, because we know that sine 90 is equal to 1. So basically at 1 there is highest destructive interference. Now this m is basically inversely proportional to lambda. If this lambda is high, then the destructive interference will be low, and when the lambda is low, basically then there will be destructive if this lambda is low, then this destructive interference will be high. If this lambda is high, then there will be no destructive interference, there will be constructive interference, right? Basically here this m, basically this m, as we have said, this m, right? M starts from plus minus 1 plus minus 2. Basically this is the opposite of constructive interference, and plus minus 3. It does not start from 0, because at 0, this is basically point 0, here we get the constructive interference, right? Basically why we are getting here the constructive interference, or we are getting destructive interference, not constructive, there is a reason. Basically, consider this as a slit, and consider that the one ray is coming from here and one ray is coming from here. It crust combine with its crust, right? And it will fall, there will be the formation of one resultant, right? Now there will be another ray and another ray, consider that their trough and their trough will also combine and they will form a resultant amplitude, right? But what will happen, its trough and its crust will cancel each other and there will be formation of destructive interference. That's why we talk about only destructive interference in this experiment, right? Now what else I was talking about, I guess okay, there is a graph of this experiment too. It's something like this. Okay, basically this high one shows the intensity. This shows the intensity, which basically shows us the maxima. This is basically the constructive interference. This shows basically this one point, right? Now this shows the maxima. Now this point basically, this is basically +1, this is -1, this is -2, and this is +2. Now here the integers are basically, the integers are showing us the destructive interference, like there's the opposite over here. So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section and I would be very glad to answer you guys.